Hey everyone, is this good at the back? Can you hear me? All right, cool. Hi there everyone. My name's Peter. I work at a company called Audax. That doesn't really matter for this speech because today I'm going to talk about some of the open source work that I currently do. So there's a project called the Open Data Contract Standard where we look to try to standardize data contracts. And hopefully today I'll give you a bit more context and a better idea about where it fits, what it does, and how you could use them. I'm part of the technical steering committee, which is just a complicated word for I make contributions. So don't worry about it too much. So to kind of break down before we go into the depth of what data contracts are, where they're used, I want to talk about the problems. So the problems that we face as data engineers that everyone I'm sure has gone through is that, pretty much every day, every hour, there's some data flows that will break. Whether they're silent or you have alerts set up, you've got monitoring or not. Some things break in ways that you don't expect or that you expect. There's unknown unknowns that you have no control over, or a bit might flip and you put your hands up in the air like you can't debug that. So most of the time when you're doing some sort of data integration, you usually start with the schema, and you kind of treat that as a developer as your golden source of truth. Where you're like, oh, great, now I can start coding because I've been given a schema. I know what columns I can use, what I can transform and do all the things that you want to do for some sort of data pipeline. But behind the scenes, there's all of these implicit assumptions that are made that aren't encompassed in that schema. So the schema just represents a small kind of piece of metadata for that data flow, but it doesn't encompass, the assumptions, who makes the data, how it's made, how often it gets refreshed, and all these kinds of things. So all that domain knowledge is either stuck in the guy who's developing it, or if you're in a large company, there will be some business analysts, there will be product owners, there'll be, all sorts of people who have, information stuck in their head that isn't part of your code. So, what usually happens is that the producer will make some change. It doesn't matter if it's a schema change. They could just change the way they calculate a field, or they've changed the way in which they've defined a field. Maybe it's, defined in a different way. Maybe it can be null now. Maybe it becomes unique or not unique. Anything can change, right? And usually the consumer is just, there at the whim of the producer and just has to deal with the problem. So on this slide, I kind of, put up some, scenarios in which you may or may not have faced before, where, we have the producers on one side where they're like, yeah, sometimes the data's late because of some upstream source. Yeah, let's slightly modify the way a field is calculated. Or now all of a sudden we'll let users input emojis. And, you've got your consumer on the right-hand side who, will interpret that and say, all right, now the file will arrive at midnight. Set the cron and we'll be good. The amount field would never change, right? Who would change that field? Or suddenly the consumer is now using the data and it's business critical because someone in management is reading from some dashboard all of a sudden. And all that's shared in between is usually just the schema. So the schema is holding everything together, but there's all this metadata that hasn't been captured yet. So essentially schemas aren't enough. We need the meanings, the expectations, and some guarantees as to when the data will come, how it's going to be used, and how it's produced. So essentially, the main problems is that these break pipelines, this can have, all kinds of effects. It has effects on not only like the data pipelines, but your team morale. Because imagine, every day if you're ingesting thousands of data sources, and a small percentage of them going wrong, that slowly kind of grinds on you day to day. You don't want to be dealing with problems every day. You want to be, doing the exciting new kind of work. So this is where I think that data contracts can play a kind of key role in kind of helping and managing these expectations or metadata and turning them into something that is explicit. So that's the key word here, is that we make all of these implicit things that are stuck in the brains of either the developers or the business analysts or whoever it is, and making it explicit. So kind of as the word contract kind of defines, that it's some sort of agreement between two parties. So our two parties here is the data producer and the data consumer. So data contract kind of encompasses that. So what we want from a data contract is that we want this metadata to be enforceable. We want to be able to take actions on that metadata. Because if you look at documentation, you could say that's metadata, but you can't necessarily take action on just some description of that data source. And we want it to be testable, because if we can make it testable, we can have our pipelines being tested in a deterministic, defined manner in which we can safely say this change is good to go or not. Then we can automate it as well. So as we make changes, we can automate, a daily pipeline to check, or if any code changes are made, we can check on those as well. And then last but not least, shareable. So we want to share these data contracts with anyone that we want to, right? Whether it's internal to your organization or outside of your organization, we want a common language that everyone can understand and have a common understanding of what that data pipeline or data contract means. So this is where the open data contract standard comes into play, where we are positioned as a vendor-agnostic open standard. So we are not controlled by anyone. We're just a bunch of people who have a common passion and interest in data contracts, and we can see that there's some real-world value in this. So originally it came from PayPal. So there's a guy called Jean-Georges Perrin. So he's the chair of the TSC right now. And he brought data contracts, the first version of data contracts, out of PayPal when he left PayPal. And I think 2 or 3 years ago, we became part of the Linux Foundation. So Linux Foundation kind of defines various governance and standards for how a project is run. So, the project is safe and isn't going to go anywhere. And it's for all data practitioners. So that could be developers, it could be business analysts, product owners, or anyone else interested in data. ODCS for short, if you don't want to say the whole thing. So why it exists is we want to make the metadata explicit, actionable, and work across different tools. Because if we have these three ingredients, it opens up the whole world of having reliable kind of data pipelines, making those implicit assumptions explicit. So the core idea behind the Open Data Contract Standard is we want to treat data like an API. So we're quite fortunate in today's world that we have the Open API standard. So for those of you who don't know, Open API is kind of the industry standard for sharing any HTTP APIs. And everyone knows and understands what it means to have an Open API doc. And you can share it outside of your organization, use it to connect to any other kind of data sources. You can use it for testing, and it's actionable, and all these great things. But that's what we're missing in the data world. We don't have this common understanding or shared standard that everyone can understand and use. So we don't want to just define the structure, but we define the behaviors as well. So just to briefly go through what is actually inside of the contract. So structure is one of the parts, but you have your constraints. So this could be, business rules, could be nullability, uniqueness, etc. Your ownership, who actually owns the data set, who's a secondary owner, who's, consumes that data, and contact details and whatnot. Compatibility. So, you have a version of some data contract. Maybe it changes, maybe you break it and you create a new data contract. You have SLAs. So SLAs, when will the data arrive? When can I expect it to arrive? How fresh will it be? Security, who has access to this data set? What kind of level of access? And there's many more. So yeah, just to give you an example of what the structure kind of looks like, I guess you probably can't see too much here, but essentially it's defining the basic kind of details that you would find inside of, a database or some, file format structure, but with additional metadata and context. So you might see, so for those of you who can't see, maybe we have this concept of like logical types and physical types, where physical types represents the actual type within the database that you're using, because Postgres uses different types, Iceberg has different types, all the different formats that we have to deal with. We have constraints, so that can mean nullability, ranges, formats, business rules. You can write your own SQL inside of here as well. You might have your own, data quality engine, so you could have Soda or whatnot that you can define your constraints inside of here. The ownership, who do you want to blame when things go wrong? You can look at the ownership section. So another kind of neat concept that you can gain from leveraging data contracts is now you have a single source of truth, because you're maintaining and defining everything about that data and how it's used and produced all in a single place. So now you can derive many different artifacts from your data contract. So you treat your data contract as your source of truth, and now you can, generate alerts from this, because you have everything defined in your data contract as metadata, and you can take action on it. You can define, monitoring. You can actually generate your code based on the data contract, and testing, your documentation, your ownership, your planning, your retention, data retention periods and whatnot. So all of these artifacts can now be thought of as generated from this source of truth, because now you have the actionable metadata. So some other examples about what other actions you can take. So now you can take, you can embed that as part of your CI/CD pipelines, because all you have is just some YAML file. It's very small, can be shared, it can be ingested, and you can validate those contracts as part of your CI/CD pipeline. You don't have to, point to some data, point directly to the production database. You can generate data because you know what the data should look like based on the contract, and you can catch those issues before production. Testing. So that's where the metadata is so expressive that you can generate production-like data without touching production. And you can validate those expectations. You generate that data, you run it through your pipeline, and now you validate it. And that's I think, a key thing missing. And governance. So governance is always kind of an interesting topic, because there's a lot of solutions out there today. We have a lot of data catalogs that are mostly some fancy UI. And then you have your data governance team that can click some buttons, but then it stops there. So the idea is that this governance, becomes embedded as part of your data contract, so that you can take action, and it doesn't matter what tool you're using. You could be using Calibra, you could be using Actian, you could be using, Data Hub, whatever it is. You can now use your data contract to export out to those data catalogs, because the data catalog is just another artifact of yours. And yeah, the other kind of key part of that is you wouldn't necessarily have this concept of migrations, because now you have your data contract, which is vendor agnostic. You would just be having some sort of translation layer of converting from your data contract to whatever tool you're using. So it could be, reading the data contract, making an API call to create an object inside of the tool that you're using, or creating another kind of file wherever it is. So yeah, in terms of adoption, some people like to go all in and say, oh, we're doing a data mesh strategy where, going to go gung-ho on data contracts and data products and whatnot. But I always suggest that you want to just start small, where you pick out your, production critical pipeline, the one that annoys you the most, and you go out and collect all that metadata that is implicit in your organization. You collect all the email trails, you pick the brains of the business analysts, and you understand, put it all down in the data contract and truly understand what that data pipeline is and what the expectations are. And then you can iterate on that. And if you don't see value, that's fine. Data contracts aren't necessarily for everyone. So I'm not here to try and push data contracts everywhere. But if you see value in it, great. If you don't, that's totally fine as well. So going back to the Venn diagram that I showed earlier, we want that end goal to be the producer and the consumer have no information that is held back from the other. Both are properly aligned in terms of the expectations and metadata that both are keeping in their head to then provide a reliable data system. You have aligned teams because everything is explicit in that data contract, and you'll have a lot less chaos because as things go wrong, you can point out directly, oh, this was part of the data contract, this is what we have agreed upon, and it's very clear and simple. You don't have to do a he said versus she said kind of scenario. Thanks for listening. If anyone has any questions. So yeah, that's a great question for those of you who didn't hear it. The question's about who enforces the data contract. The great part about the data contract is both sides could enforce it. The producer can create their own tests and validations to ensure the data that they're producing adheres to the data contract in which that has been created. And the consumer can enforce and create tests and validate that the data coming from the producer adheres to that data contract. So that becomes a difficult point, because at the point of the high level idea of the data contract is both have agreed to the data contract at that point in time. If there's a disagreement, then there was technically a disagreement at the point in time in which the data contract was created. So the idea is that it's so explicit, the metadata, that if someone does have a disagreement, it should be at that point in time it's created. Kind of similar to like a legal contract. Like you could go back and say like, hey, I don't want to pay you $1,000 for this job. But if it's in the contract and the person's done the job, then, and you both agree to it, you might have to still pay up. So, yeah. So the question's about how do you kind of validate the DTO or the data contract itself. So there's some open source tools. There's a popular one called the Data Contract CLI. So it goes back to the concept that I kind of showed here, where the Data Contract CLI is a tool that can read the Open Data Contract Standard in the YAML format and generate any number of different artifacts. So it can generate SQL It can generate, I think, the SODA data quality rules. It can generate all these different kinds of artifacts just based on, your data contract. There's a bunch of other tools available, which you can see in the, if you go to the Open Data Contract Standard GitHub, you'll find there's a bunch of other tools that are available as well that you can use. Yep. So for those of you who couldn't hear, maybe the question's mainly about if you have data contracts that you already have defined ownership and you have a lot of tests. Is there any tools or advice to avoid alert fatigue, essentially? I think alert fatigue is like a big problem. I don't think there's a good answer I could give you. Data contracts doesn't solve this issue. It provides kind of a framework in which you can decide how many tests you want. If you want to go crazy with tests and constraints and validation rules, you're allowed to do that. But usually it comes, whenever I think of alerts, there's always some sort of priority to those alerts. So I think, I don't have the example here, but if you go to the Open Data Contract Standard, you can define the type of data quality rule. So there's things like conformity, uniqueness, freshness, and these kinds of things. And you can decide what ones are most critical for you that you need to be alerted and action on now. So there's sufficient metadata around the data quality rules in which you can filter out, say, I don't care about the conformity rules, or I don't care about, this other metadata type of rules. So it gives you the optionality, I guess, of you might have 1,000 rules, but you only care about 10 to get alerted from. There's no good answer to alert fatigue, I feel. Yeah.